Hello everyone, this is Sujata, Associate Professor working at Government College for Women, Kolar. Now this presentation is for final BSc students belonging to Bangalore North University, and this is on Chemistry Paper 5 Organic, and this is Session 17. This is the last session under heterocyclic compounds, and the title of this presentation is Fused Heterocyclic Compounds. Objectives of this session is to understand what are fused heterocyclic compounds and their examples, preparation of indole, nitration of indole, and preparation of quinoline by Skraup's method and how it undergoes nitration. Learning outcomes: to understand what are heterocyclic and fused heterocyclic compounds, methods of preparation of indole and quinoline, nitration of these two compounds. Prerequisites: there are different cyclic molecules. Simplest among are alicyclic, aromatic. Under alicyclic we have homocyclic and heterocyclic. Among the heterocyclic we have 5-membered, 6-membered compounds, and fused heterocyclic compounds are those where two rings fuse together. The synthesis reactions can be learned under name reactions and how they form products upon nitration. Coming to fused heterocyclic compounds, these are the compounds containing two rings which are fused with one another. Here you can see benzene ring is fused with pyrrole or pyridine. So therefore these are also called as benz fused compounds or condensed heterocyclic compounds. The important examples include indole, which is also called as benzopyrrole, quinoline and isoquinoline. Now coming to the preparation of indole by Fischer's method. In this method, phenylhydrazine is treated with pyruvic acid to form corresponding phenylhydrazone. This is heated with anhydrous zinc chloride to give indole 2-carboxylic acid. This, on heating, loses a molecule of carbon dioxide to form indole. Here we can see the mechanism of this synthesis. Phenylhydrazine, when reacts with pyruvic acid, there is elimination of one water molecule to form phenylhydrazone. This is a type of condensation reaction. Then hydrazone formed reacts with zinc chloride and upon heating undergoes deamination and ring closure to form indole 2-carboxylic acid. This, upon heating, undergoes decarboxylation to form indole. Coming to the nitration reaction of indole. Nitration is an example of electrophilic substitution reaction. When an electrophile attacks indole, there can be two possibilities. Either it can attack at C2 or at C3. Here you can see different resonating forms, and the most stable cationic form is when the substitution occurs at C3 position, whereas when the attack is at C2 position, the cation form is less stable. Therefore, indole, when undergoes nitration with nitroethane in presence of sodium ethoxide forms 3-nitro-indole. In this slide, we can see the synthesis of quinoline by Skraup's method. In this method, aniline and glycerol are heated in presence of sulfuric acid, nitrobenzene and ferrous sulfate. Nitrobenzene in this reaction acts as a mild oxidizing agent, and ferrous sulfate makes the reaction less violent because the reaction is exothermic in nature. Getting into the mechanism of Skraup's synthesis of quinoline. In the first stage, glycerol, when heated with concentrated sulfuric acid, undergoes dehydration to form acrolein, which is aldehyde having a double bond. This acrolein approaches aniline to form an intermediate, and this intermediate further undergoes cyclization in presence of concentrated sulfuric acid to form 1,2-dihydroquinone. This, when undergoes oxidation in presence of nitrobenzene, loses these two hydrogen atoms in the form of water to form quinoline. In this slide, we can see how quinoline undergoes nitration in presence of nitrating mixture to give 5-nitro and 8-nitro-quinoline. So, we understood the fused heterocyclic compounds include indole, quinoline and isoquinoline. These are the heterocyclic compounds containing two different rings, benzene and 5-membered or 6-membered rings, and how this can be prepared by different methods. Indole can be prepared by Fischer's method, while quinoline can be prepared by Skraup's method. Both upon nitration give 3-nitro product, and in case of quinoline it gives rise to 8-nitro and 5-nitro-quinoline. Coming to MCQs, the first question: dash and dash are the starting materials for the synthesis of indole by Fischer's method. The right answer is phenylhydrazine and pyruvic acid. During the synthesis of quinoline, nitrobenzene acts as oxidizing agent. Third question: quinoline is an example for fused heterocyclic compound. Fourth question: quinoline on nitration gives 5-nitro and 8-nitro-quinoline. That is the right answer. And the last question: glycerol on dehydration with concentrated sulfuric acid gives acrolein. References: New College Chemistry by Y.R. Sharma, Advanced Organic Chemistry by Arun Bahal and B.S. Bahal. Thank you.